when it comes to verifying these trig equations, right, since we are trying to show that these two things are equal, yes, it's already kind of written that they're equal, but since we're trying to show these two things are equal, right, things we cannot do. We cannot add the same thing to both sides. We can't multiply the same thing to both sides. We can't subtract or divide the same thing to both sides, right? Those properties of equality are out the window because we haven't really shown these are equal yet. We're trying to show that they're equal. So by using that idea of the equality properties, addition property of equality, subtraction, multiplication, division properties of equality, okay, you're kind of putting the cart before the horse. We need to, we can't use that. We can't use that until we show they're equal. Okay. So logically, we can't use that yet. All right. So in other words, what we need to do then is focus on a side, right? Traditionally, the way these problems are set up, the left-hand side is kind of what you're supposed to work with. The right-hand side is what your goal would be. Okay. And the reason for that typically is that the left-hand side is kind of more messy or more complicated, and then the right-hand side is more simplified. So it's easier to take something that's unsimplified and simplify it, rather than take something that's simple and then trying to tease it out or complicate it to the point where we get to this left-hand side. All right, so that's kind of the idea here, right? So, some general kind of guidelines when you come across a problem like this, right? If you look here, for example, the left-hand side, it's got addition between two terms, right? We got sine theta, that's the first term, and then plus, and then cosine theta, cotangent theta, second term. Here, on the right-hand side, we only have one term. So ideally, we want to try and eliminate that addition somehow, and maybe combine things together there. All right? So, any ideas about what we can maybe start doing here to help us out with this left-hand side? What should we maybe do? How should we maybe start out? Any ideas? And that's okay if you don't. So I see, for example, that we've got sine theta plus cosine theta times cotangent theta there. So I see that cotangent, and we have sine and cosine here, but that cotangent is, not sine and cosine, but we could write it in sine and cosine. So let's write it. Okay, like that, yeah? Same idea. And I'm not going to keep writing the cosecant of theta. That's just, why bother? We know what it's going to be. The right-hand side is cosecant theta, so I'll just leave it equals there. Okay. So now I can put these terms together, and I'll get sine of theta plus, it'll be like cosine squared of theta over sine of theta. And again, that's going to be equal to that cosecant there. All right, so I did that, but now it's like, is this helpful or not? Okay, so we really want to, ideas? Brian, you have an idea?
Can we get sine over cosine?
Can we get sine over for the sine right here, you mean?
Yes.
So we want to so how would you want to put that over cosine? Not sure? Not sure? No?
Not sure.
Yes, okay. So again, let's take a look here. We've got a sum of two things, but we want to get just one thing. So to add these two things together, to be able to add these two things together, what do we need? Common denominator. What will our common denominator be? Sine of theta. So we'll have to multiply here by sine theta over sine theta. Okay, we've got to. Right, get that common denominator. And so then that'll result in sine squared theta over the sine of theta plus cosine squared theta over the sine of theta. And we can combine those together to make then just sine squared theta plus cosine squared theta, over sine of theta. So now we have one term, so we're making progress here. We kind of have one term. Yes, there's still addition in the numerator there. We do kind of have it all as one big thing. So how can we proceed from here? Any ideas? Matt?
I'm pretty sure the top equals 1, and then that's supposed to be...
Yep. 1 over the sine of theta is equal to the cosecant of theta. Check. Okay. So we're done. There it is. Okay. Sine squared plus cosine squared is 1. Pythagorean identity. Okay. Now, maybe when we first had this step right here, maybe some people saw that step right there, and they're like, cosine squared. We can manipulate our Pythagorean identity of sine squared x plus cosine squared x equals 1. We can change this cosine squared to be 1 minus the sine squared. And yes, you can do that. Now, why might this be a good strategy? I just told you guys that maybe we don't want to try and make things more complicated. We want to try and simplify things down, right? So here we are taking sine plus cosine squared over sine, and we're making this cosine squared kind of more complicated, right? We're adding in kind of like some subtraction. So now we have addition and subtraction in here. It kind of makes it a little more tricky. But it's helpful because now we have everything in terms of sine. So potentially things could cancel out and stuff. And in fact, some things do cancel out, right? We've got 1 over sine theta. If I break up this fraction, or you can break a fraction up over its numerator. So for example, the 1 minus sine squared theta in the numerator can become just 1 over sine theta minus sine squared theta over sine of theta. Okay. Now, how will things simplify from here? What's going to happen? What can happen here from this point? Devin, yeah?
Can you add like terms?
Okay, so what like terms? There will be, but we have to do something. We have to simplify first. What can we cancel out? I'll zoom in on this more here. What can we cancel out here? Matt?
Can you just make sine squared theta over sine squared sine? Sine theta.
Yeah. Sine squared theta divided by sine theta is sine of theta, right? You have sine squared divided by the same sine, and so they'll just cancel out. That'll become just a 1 there, and that's now gone. And so we're left with sine of theta plus 1 over sine theta. By the way, what is 1 over sine of theta? Cosecant. Minus sine squared over sine was just sine of theta. Oh my gosh, the signs cancel, and it's cosecant theta equals cosecant theta. Okay. So there it is. All right. So my purpose there is not to confuse you, showing you multiple different ways to do it. My purpose is to show you that there are multiple paths, right? And so just because you are doing it in a way, then your friend or neighbor may be doing it in a different way, that might still be valid. Okay, it still might be valid. Okay. But again, what are helpful strategies versus not helpful strategies? Okay. So what are helpful? First of all, rewrite things. Maybe consider rewriting things in terms of sine and cosine, right? Because then you can get things to cancel out or combine together, right? Consider looking for those Pythagorean identities. Trying to get, if you see you have one term, but here we're adding together two different terms, try and get those two different terms together to get the one term there. Alternatively, you could also try and rewrite everything in terms of just like a single trig function, so that we can really cancel out, if possible. Look for those squared terms, use Pythagorean identities, look for reciprocal things, and just try and get things to cancel out. Okay. There is no do this every time and it will work. It's kind of like you got to, it's got to play around with it a little bit sometimes. All right. So let's try another one here. Secant x minus tangent x times cosecant x plus 1 equals cotangent of x. Okay, so again, we want to verify. Okay, this is just like number 2. Same directions, we're going to verify the following trig equation is true. Okay, so now if you look here, we have a binomial, secant minus tangent, times another binomial, cosecant x plus 1. Okay, so ideas here. Ideas here?
Distribute.
Distribute. Great idea. And it's going to have to FOIL here, right? Because we have a binomial times a binomial. So it's going to be secant x times cosecant x, which is secant x cosecant x. Okay. And then let's see here. That was the first. And then the outer plus secant x. And then the inner minus tangent x cosecant x. And then minus tangent x. And again, we're shooting for that cotangent of x there. Okay. So be careful how you FOIL it out. Make sure you do it, correctly there. How you distribute it out. Okay, does anything cancel as a result of doing that? Looks like no. All right. What would maybe be a good next step here then? What would maybe be a good next step here? Okay, like so factor by grouping you're saying?
Yeah.
So we could factor by grouping. I think the problem with if we do that factor by grouping, we're going to end going back right to where we were though, because we just multiplied it there. If we factor by grouping, it's going to go right back to where we were, right? Because we just multiplied it, so now we're basically going to unmultiply by factoring there. Yeah. Yeah. We're going to end up back where we started. Okay. And again, you would have seen that when you did it. You're like, oh, and then, All right. No ideas? Okay. Well, nothing is written in terms of sine and cosine yet, so let's maybe try that, right? So secant of, and I know this is going to make it look yuckier, but at least we'll be able to maybe potentially simplify things. So secant of x is 1 over the cosine. Cosecant of x is 1 over the sine. Secant of x is 1 over the cosine. And then tangent x cosecant x, that's, oh goodness, sine x over cosine x times 1 over the sine of x. Minus, and then tangent x again is sine of x over cosine of x. Okay, or in other words, 1 over cosine x sine x, or if I just multiply these two fractions together, it's cosine x sine x in the denominator, plus 1 over cosine x minus sine x over cosine x sine x minus sine x over cosine x. Okay, so all I did there was I just multiplied these two things together to get that, and these two things together to get that. Okay. Again, folks, remember our goal here is cotangent of x, a single term. Right now we've got 4 terms being combined together here. We want to get that down to a single term. You can see here we've got a bunch of fractions, right? So what might be a good strategy here to try and get these 4 fractions down to a single term, or at least a single fraction? How can we combine all these things together? What do we need?
Can you add like the common denominators together?
Yeah, we can combine those together. Okay, so then we would, let's see here. So the cosine and sine are similar, so we'd get 1 minus sine x in the numerator there over cosine x sine x. And then we can do this other one here, which is another 1 minus sine x, and that's over just cosine x. If you want, you can put like a little question mark above there if you want to, or something like that. Does it equal will be? Okay. Well, we got like numerators, or we have common numerators, but that is not helpful when it comes to adding fractions together. And we still have 2 fractions here instead of just the 1. Right, Brian?
You can multiply the second term by sine x over sine x.
Yes, sine x over sine x. Okay, so get a common denominator here, right?
Yeah.
So we have 1 minus sine x over cosine x sine x. And then let's see, when I multiply that numerator by sine x, what's going to be in the numerator now? Sine x minus sine squared x. And that's over cosine x sine x. Okay. And so now that we have these common denominators, we can put those numerators together. What's going to happen with our numerators here? What are we going to end up with?
1 minus sine squared x.
Yeah, the minus sine x plus this positive sine x are going to cancel. I'll have 1 minus the sine squared of x over cosine x sine x. Okay. All right, we're making progress here. We got one fraction, but we still have that. We have a 1 minus sine squared x. Julia's like, we're not making any progress here. Okay. So you don't. So no idea still what to do from here. Do we see it yet? What's 1 minus sine squared? Cosine squared.
Is that root to 1 minus sine squared?
If you subtract sine squared, so this is an identity, right? So that means it's true. So we can like do the same thing to both sides, kind of thing. And so we end with cosine squared equals 1 minus sine squared. These, right? We can't do the same thing to both sides because it's not an identity. We're trying to show that it's an identity. So that's why. So yeah, now what can we do? Yeah, we got a cosine squared and we got a cosine. So one of those can cancel out with one of those. I'm just going to go this way because we're out of space here. We're left with cosine x over sine x, and oh my gosh, that's cotangent x. We got it. No problem, right? Easy. Ready for the quiz, Mr. Widd.
That's hard.
Look, it's just half a page, guys. Come on. How bad is that? Just half a page. Okay. All right, well, I guess we better try another one then. Guess we better try another one. Guess we better try another one then.
Memorize stuff.
Yeah, just memorize it. That's all. Just memorize.
I was here.
School was so weird during that.
Evan, I'll be back. Don't worry.
All right. Okay.
You can make it 1 over tangent, like 1 over. Can you split them up?
So a denominator we can't split up, right? Yeah, I think I see what you're trying to say. But the thing is, so for example, let's think about it this way. If you have like 1/5, right? That is equal to 1 over 2 plus 3 like that. But it's not equal to, in general, 1/2 plus 1/3 like that, right? Unfortunately not. And again, these are things you guys can do, right? When you're in the middle of like, some sort of exam or, just in a math class or taking an SAT or something like that. You're like, can I do something like this? Like, if you're not sure, if you want to try and break that up, just break it into rewrite it in like another kind of way and see. Oh, is 1 over 2 plus 3 the same thing as 1 over 2 plus 1 over 3? In general, no. In general. So we can't break up the denominator like that. Okay. So, ideas here? Well, not everything is in terms of sine and cosine, right? We've got tangent and cotangent. Mr. Wade, you're going to make us put fraction within a fraction? Yep. If you look here, our denominator, is separated by addition, right? But if you look over here, again, we've got kind of like one term. It's a product. It's one term. So we want to try again and get one term here. So what can we do here? What can we do to combine that tangent x and the cotangent x? Or what can we do here to combine sine x over cosine x plus cosine x over sine x? So let's go Devin here this time. Yep. Multiply by something, yes. But we can't, so right now, what are we going to multiply this by? What does this one need in the denominator that this one has? Yes, they need each other basically. Exactly right. So we'll do sine of x. Oh, they need each other. Okay, so sine of x over sine of x times cosine x over cosine x. Okay, so there it is. And so when we multiply and get that common denominator in the denominator,
So like,
Oh, I get it.
you're making it so you can add this to the bottom, so
yep.
I can multiply by one.
I get it.
Uh-oh, Alyssa says she's got it.
No,
Okay.
just like this. Like
Just this
this.
one step. Hey, that's still progress. That's good. I'll take it. Okay? Right? Common denominator. Now, why is that helpful? Because now we can combine this all together, right? Yes, now we have sine x, cosine x, sine x, sin x, but we're going to have sine squared plus cosine squared. So another reason why I like these is because it requires a lot of like algebraic manipulation, stuff that maybe we haven't done a whole lot with recently. Where's my 9? Okay.
Why? Was it square to begin with?
No, but because we had to get those
Yep, yep. Got
common denominators.
Yep.
Okay. Now, if you remember back to like Friday, right? For those of you guys who remember back to Friday, or were here Friday, right? We had fractions within fractions, right? We got 1 over, this is our denominator, this whole fraction. So instead of taking 1 and dividing by this quantity, we can do 1 times the reciprocal of this quantity, which is sine x cosine x over, and what's sine squared plus cosine squared? 1. Oh my gosh, there it is. Okay.
Wait, Mr. Red,
Question.
what did you just multiply by?
We have 1 being divided by this fraction.
Yeah.
So instead of dividing 1 by that fraction, I multiplied by its reciprocal.
Isn't that not its reciprocal?
Well, I may skip too many steps here. Right? Reciprocal. But what is sine squared of x plus cosine squared of x?
It's
1. Right. So not only are we using all of our algebra knowledge from, past years, we're also now incorporating in these trig identities, right? And so we want to keep our eyes open for, when you see a squared trig function with a +1 or a squared trig function with a -1 or 2 squared trig functions kind of thing, keep an eye out for those to then try and use that Pythagorean identity. And so then we get that right there. All right? You guys ready to try one? Yeah. Okay. What's that? You didn't do any of those. I did them all. Some of you guys did. Sorry. I apologize. You're right. Some of you guys did do them on your own. Okay. So here, you guys try one. I'll just try.
Yeah.
Do you know how to do these? Oh, okay.
Yes, Matt was sleeping the entire time, even when he answered my question.
Oh my god. You think it's good? I do.
All right. So here's one for y'all to try. Y'all try this one out. All right. So there it is. Verify that is true. So I will give you some clues maybe, some thoughts to think. Okay, maybe to help. I see here, for example, that we're adding two things together, and we're shooting for a single term. So perhaps we want to get a common denominator here, right? Because right now we have two things being added together. We need to get those together to be a single thing. How do you add these two things? Well, we need to get a common denominator. Idea 1. Okay, idea 1 there. I think that's probably the most clear. There are other ways about going about doing this too. show you an alternative way to go about this on the side. I'll walk around to hear your complaints and see your frustrations. Okay, so this is not what you were using the Pythagorean identity. So this is only, that would only be true if it was secant squared x minus tangent squared x. Yeah, Pythagorean identities require the squared. That's all. Yep. Now, for example, Stella, like up again up there, you see you have a 1 plus cosine. And you would multiply that fraction by 1 minus cosine over 1 minus cosine. You would have a difference in squared at the top, so it'd be 1 minus cosine squared, which you could then make the sine squared. So that's the other way. I'll be showing you guys. So you can kind of like make a Pythagorean identity show up as well. Sometimes that's helpful. Question, Brian?
What do you got?
Okay. So again, I see two fractions here. I see one fraction here. So how can you combine these two things together? What do you need? So what is this denominator missing that this denominator has? Sine. What's this one missing? So let's go ahead and take care of it. Do it now. Okay. Yes.
Do this right.
You think you got it? Yep. Sorry, I didn't mean to buzz your thumb there.
Can, yes you can, baby. No, don't go away. Don't leave it.
Okay, so there's some good things here, but there's some mathemagic things going on here too. Mathemagic, that's right.
I
So
don't get it.
this should be sine squared in the numerator, right? When you do your common denominator, it's sine over sine. So you should have sine squared in your numerator here. Okay. And then here, this number is missing a 1 plus cosine. So it should be cosine times 1 plus cosine, right? Right. So I just X this answer. Okay. So then the signs can't quite cancel out that because of the addition. But now let's see here. This is sine squared now. Okay. So now I see a sine squared and a cosine squared. So that'd be 1. So why don't you go from here and see what you can come up with here. Okay.
Well, like I'm not doing this.
I see what you're saying. You can't cancel like this. So hang on a second. Let me just go back and make sure everything else is good up to that point then. Okay, yeah. And these can't quite cancel out because you have this addition up here like this. So, but you're on the right path though. So this is right. So from here, what can we do? We can distribute the cosine. So we'll have cosine squared plus sine squared though, which will be 1, and you have another cosine up here left. So you'll have cosine theta plus 1, then you cancel with 1 plus cosine.
Okay.
You see it?
Like you have to make everything 1/4 up here before you can cancel.
Simplify it, yeah. So you can't. So for example, let me show you this. have something like this. I just made this up. The cosines, they can cancel here. This cosine and this cosine, they can cancel because it's a product here, cosine times something, and then over a product here. Okay, so in other words, why we can do that is because we can take this fraction and it's equal to right, we kind of like essentially just take these two pieces out and then rewrite the product as this. See what I'm saying? So that's why, okay, boom, you can cancel it. Okay, what we can't do though is we can't cancel out the signs here because this is sine of theta, but the sine of theta has a plus cosine theta in there, so we can't just like cancel that out the way you want to there. So because it's not just sine theta, it's sine theta plus cosine theta. So with what you were doing there, yeah, you can't just cancel out from a sum. Okay. When we're dealing with fractions, folks, if you have stuff in the numerator and stuff in the denominator, you can't cancel out from a sum, but you can cancel out from a product. Okay, maybe that helps to distinguish things a little easier here. Okay. So I suggested that we get a common denominator. So let me just go ahead and take care of that. I'm going to assume that that's what everyone went with first, just because if Mr. Whitmire says it, then it must be true. Okay. Why would I ever lead you astray? All right. So to get our common denominators here, what is this denominator missing? Sine. So we'll do sine theta over sine of theta. What's this denominator missing? Hold on. 1 plus the cosine. So we're going to multiply then by 1 plus the cosine. So this is non-calculated. Okay. But you can still keep your formula sheet there if you'd like. All right. So I'm going to run out of space here, so I'll just make a big old. Okay. And so now it's super imperative here that we multiply this accurately. So sine times sine will be sine squared. I'm not going to distribute this out. I'm just going to leave it. Sine theta times 1 plus cosine theta. Okay. Plus, and then I'll distribute on the numerator here. Cosine theta times 1, right, is cosine theta. Cosine times cosine is cosine squared. All over, and again, sine theta 1 plus cosine theta. Okay. So there it is. Now, we have common denominators. You can combine things together. I'll go ahead and do that. Okay. Now, things that we can't do here. Things that we can't do. We can't cancel out the sine squared and the sine here right now. This sine is a product, so it's ready to be canceled out by something, but this sine is part of a sum. Okay? If this sine was like factored out from something, then yeah, the signs could cancel. But right now, since it's part of a sum, we can't cancel out with the sine of theta. This is part of a sum. This is part of a product. Okay? So we can't cancel them out like that. Okay? So, what do we have here, though? What do we have here in the numerator? Yeah, right, Robert. So we can rearrange addition, right? 1 plus 2 plus 3 is the same thing as 1 plus 3 plus 2, right? We can add these two things together. So you get 1 plus cosine theta over sine of theta times 1 plus cosine theta. These two things, like when you have addition, three things being added together. It doesn't matter the order in which you add those things together. 1 plus 2 plus 3 is the same thing as 1 plus 3 and then plus 2 at the end. What's sine squared plus cosine squared? I skipped that. I just made it 1. 1. Okay. So I just rearrange the terms in the numerator, which is allowed because we have addition here. Okay. Now, why is this significant? Yes. This 1 plus cosine theta is the entire quantity in the numerator, and then we can divide that and cancel it out with the 1 plus cosine theta in the denominator there. Okay. Again, the idea is we could rewrite this thing that we had here as 1 over sine theta times 1 plus cosine theta over 1 plus cosine theta, right? We can rewrite it in such a way that, yes, obviously these things can cancel. It's 1, right? This fraction right here is the same as this fraction. Those cancel, and so we're left with 1 over sine theta. But what's 1 over sine theta? It's cosecant theta, which was our goal. So check. We done. Okay. All right, I'll show you one more thing here. I'm going to have you guys start on the assignment. This problem right here, the 1 plus cosine theta in the denominator, okay, that's almost a difference of square. Or it's almost, well, it's almost not a difference of square. It's almost our Pythagorean identity here.
So like, if you know that identity for sine squared x plus cosine x equals 1, it's in the numerator, sine theta plus cosine theta. So you just change that to 1.
Right, Julie, you had a question. Sorry, what was your question?
I don't know.
Trying to take it all in?
Yeah.
So you can take part of it, yes. Okay. Yeah, so we'll get you started on something. Yeah, no problem. Okay. I'll get you started on the calculator, the non-calculator section. And then you might not have quite enough room there. You can take there's a desk way in the corner there next to Noah, and you can just kind of move it against the wall or something like that. That way you don't get distracted or anything. Okay. So just one other idea here real quick I want to show you. This right here, sine theta over 1 plus cosine theta, we could multiply that by 1 minus cosine theta over 1 minus cosine theta, and still have the plus cotangent there. Okay, so again, this is an alternative method here, alternative strategy. Sine times 1, sine times minus cosine. Well, I'm going to leave it undistributed actually for right now. Just leave it like that. 1 plus cosine theta times 1 minus cosine theta is going to be what? What's this product going to be here? It's a plus b times a minus b. Difference of squares, yeah. So it's going to be 1 minus cosine squared theta. If you FOIL it out, you would see that that's what you're going to get here. You get 1, you have minus cosine theta, you have plus cosine theta, so those will cancel, and then minus cosine squared. Why is this significant? What's 1 minus cosine squared of theta? Sine squared. So this is just, again, an alternative way of approaching these. Sine over sine squared. Okay, we're left with 1 minus cosine theta over sine of theta. Okay. And now if I break up my numerator, I have 1 over sine theta minus cosine theta over sine of theta plus cotangent theta. But what is cosine theta over sine theta? The same as what trig ratio? Cotangent. We have a minus cotangent plus cotangent. What's 1 over sine? Cosecant of theta. Okay. So there you go. All right. So that's the idea. All right. So I'm going to get you guys started on your assignment here because I think the only way that we're going to really get the hang for these, okay, is to wrestle with these some more. Okay. Mr. Whitmire just feeding you answers and doing the work for you, not going to be helpful. So here we go.